welcome to The Explainer. Today, we're diving into a really radical new theory, one that completely rethinks one of the most fundamental things in our universe, gravity itself. Okay, let's just jump right in with a question that's, well, it's a big one. We feel gravity every single moment of our lives, but what if our whole idea of it being a force is just wrong? What if it's something more like an echo or a side effect of the universe's engine humming along?
Now, to really get why this new idea is so wild, we've got to do a quick recap of the story of gravity as we know it. And really, it's a story with two main characters. First, you've got Newton. He gave us this picture of gravity as an invisible rope, a mysterious force that pulls an apple down from a tree. Simple, effective. But then Einstein comes along and just completely changes the game. He says, nope, there's no rope. What's really happening is that massive things like planets are literally bending and warping the fabric of space and time itself. And that apple, it's just rolling down the curve. That was a huge leap in how we see the universe. But what if Einstein's revolution wasn't the final chapter? There's a new model on the block, part of that grand quest for a theory of everything, and it proposes an even more radical jump. It's called the Harmonic Scale Framework, or HSF for short. So here's the absolute core of it. The HSF model says gravity isn't a fundamental force like, say, electromagnetism. It's not even a main character in the play. Instead, it's what's called an emergent property, a consequence of other stuff happening in the background. You know, think of the beautiful patterns that ripples make on a pond. The ripples aren't a force themselves. They're just a side effect of a stone you threw in. HSF says gravity is kind of like that. So what is this framework? Well, HSF imagines the entire universe as this grand cosmic instrument. And in this picture, everything, every particle, all energy, every field is just a vibration, a little subwave that's part of one single total wave. And these vibrations aren't chaotic. They're neatly organized into different harmonic channels, almost like different octaves on a cosmic piano, with each channel playing its own specific part in the symphony. All right, so if gravity is just a side effect, then what's actually causing it? Well, in the HSF model, it all comes down to a flow of energy between three of these key cosmic channels. Let's meet the main players here, which the theory labels with K numbers. First up is K4, the Neutrofield. The easiest way to think about this is as an energy depot. It's where matter stores its rest mass energy. Then you've got K6, the Continuum. That's the elastic background of space-time itself. And connecting them is the crucial player, K5, the cosmological coupling. Think of it like a conveyor belt, moving energy between the depot and the background.
And this flow is a process HSF calls downcoupling. It's pretty straightforward. First, matter piles up its energy in that K4 depot. Second, the K5 conveyor belt kicks in and starts routing that energy. And third, as that energy flows, it creates a strain on the K6 background, creating tension in it, just like pulling on a giant rubber sheet.
And right here, this is the punchline. What we feel and measure as the force of gravity is nothing more than the slope or gradient of that tension in the background. Objects aren't being pulled by some invisible force. They're just following the path of least resistance, the path of least tension, like a marble naturally rolling to the lowest point on that stretched rubber sheet. Okay, so you can see how this one idea completely changes the picture. And this isn't just about gravity. When you redefine something this fundamental, it sends ripples through, well, everything. Let's see what else this changes. Let's talk about the dark universe. You know, one of the biggest headaches in cosmology. To make the universe work, the standard model has to invent two totally mysterious things: dark matter and dark energy. HSF says, maybe you don't need them. Instead, what we call dark matter might just be the gravitational effect of all that energy packed away in the K4 depots across the universe. And dark energy, that could be explained by the dynamics of that K5 coupling channel. No new stuff needed. And you know the famous gravitational constant, big G? Well, it kind of gets a demotion here. In the standard model, it's this fundamental, unchanging number literally baked into the code of the universe. But in HSF, it's not fundamental at all. It's an effective constant that just emerges from how strongly those K4, K5, and K6 channels are linked. And here's the really wild part. If it depends on that coupling, the theory says its value might actually change slightly at different cosmic scales. Even neutrinos get a whole new job description. Instead of being just another fundamental particle, HSF sees them as overflow from that K4 energy depot. When an atomic nucleus does its thing, like fusion or decay,
it has to retune its energy level. Any leftover energy that it can't store gets kicked out as these free K-force subwaves. And that's what we detect as a neutrino. This all ties together really nicely, doesn't it? But a beautiful theory is only as good as its predictions. Can it be tested? And more importantly, can it be disproven? According to HSF, yes. It proposes some very specific, observable fingerprints we should be able to go out and look for. So here's what to look for. The theory predicts we should see tiny, axis-related patterns in astronomical data because of the way objects are shaped. It predicts that we might actually find tiny differences in the gravitational constant if we can measure it at vastly different scales. And maybe the most direct test, it predicts a direct link between patterns of neutrino emissions and local changes in gravity, since they're both tied to that K4 energy depot. These aren't vague ideas. They are concrete, falsifiable predictions.
And that leaves us with one final, absolutely mind-bending thought. If HSF turns out to be right, if gravity isn't a fundamental force, but a mechanism, an elastic tension that we can influence by managing energy flow, does that mean we could, in theory, learn to manipulate it? Could we one day figure out how to control that flow, maybe even reverse the tension and trick gravity? The theory suggests a physical pathway exists. Whether we could ever build the machine, well, that's a profound question for the future.